let us start. Okay, if alpha and beta are zeros of the polynomial x square plus 8x plus 6, then if we, now we have to find the polynomial whose zeros are in the form of 1 by alpha and 1 by beta. Okay, and 1 by alpha square and 1 by beta square. Then we need to find the value of 1 by alpha, 1 by beta by alpha, and 1 plus alpha by beta, and then we need to find the value of alpha minus beta and alpha plus beta. Before that one, let us take an example that if alpha value is 4 and beta value is 2, when if we need to find the value, if we need to find the polynomial whose zeros are 4 and 2, means sum of the zeros, that is alpha plus beta value is 4 plus 2, that becomes 6, and if the product of those two zeros are 4 into 2, that is 8. Okay, we use this formula to find the polynomial whose sum of zeros are known and product of zeros are known. Okay, we shall substitute the value of alpha plus beta value is 6 and alpha beta value is 8 in the equation. Okay, k into x square minus alpha plus beta value is 6 into x plus alpha beta value is 8. Okay, where k is any natural number. Okay, we can give the any natural value of k in the natural numbers. Okay, let us give the value of k as 1. Okay, you can give any values in the natural numbers. Okay, so 1 into x square minus 6x plus 8. Okay, 1 into x square is x square minus 6x plus 8. So polynomial is x square minus 6x plus 8 if alpha is 4 and beta is 2. Okay, in this way we will find the polynomial if we know the zeros of that polynomial. Okay, we find the value of alpha plus beta, that is zeros of the polynomial, and we find the value of product of those two zeros. Then we substitute that in the x square minus alpha plus beta of x plus alpha beta. We will get the value of, we will get the required polynomial. Okay, this is the procedure how we find the polynomial if the zeros are known. Okay, similarly here they have given that alpha and beta are the zeros of the polynomial x square plus 8x plus 6. Now if alpha and beta are the zeros of this polynomial, we need to find another polynomial whose zeros are in the form of 1 by alpha and 1 by beta. Okay, so we shall find the sum of zeros, that is 1 by alpha plus 1 by beta, because 1 by alpha and 1 by beta are the zeros of the polynomial which is unknown now. Okay, let us find the sum of zeros. Okay, that means if we add the LCM is alpha and beta, so we'll get the numerator as beta into 1 is beta plus alpha into 1 is alpha. Okay, so the numerator is alpha plus beta by alpha beta. Okay, so now we shall find the sum of zeros of alpha and beta, that is alpha plus beta is equal to minus b by a minus of 8 by 1. So alpha plus beta value is minus 8, and product of zeros alpha into beta is equal to c by a. So c value is 6 by a value is 1. Alpha into beta is equal to 6, and sum of zeros, that is alpha plus beta, is minus 8. Okay, let us use this alpha plus beta and alpha beta in this equation, that is sum of zeros. Alpha plus beta value is a minus 8 by alpha beta value is 6. So sum of zeros is minus 8 by 6, that is we can simplify as minus 4 by 3. Okay, similarly we shall find the product of zeros. Product of zeros, that is 1 by alpha into 1 by beta. We get 1 by alpha beta. So alpha beta value is 1 by 6. So alpha beta value is 6. So the product of zeros is 1 by 6. sum of zeros is minus 4 by 3. We shall substitute these two, sum of zeros and product of zeros, in the equation. That is, sum of zeros alpha plus beta value is minus 4 by 3, alpha beta value is 1 by 6. Okay, x square minus alpha plus beta, sum of the zeros value is minus 4 by 3, minus of 4 by 3 of x plus alpha beta values, that is product of zeros value is 1 by 6, 1 by 6. Okay, k into x square minus of minus plus 4 by 3x plus 1 by 6. Now we shall give the value of k as the multiple of 6, that is, we shall give the value of k so such that denominator can be eliminated, denominator can be removed. So take the value of k in such a way that the LCM of the denominators. Okay, so 6 into x square plus 4 by 3x plus 1 by 6, 6 into x square, 6x square plus 6 4s are 24x by 3 plus 6 1s are 6 by 6. Okay, 6x square, 3 1s are 3 8s are plus 8x plus 6 1s are 6 1s are 1. So required polynomial p of x is 6x square plus 8x plus 1. Okay, 6x square plus 8x plus 1. This is how we can find the polynomial whose zeros are in the form of 1 by alpha and 1 by beta. We found the value of the sum of the zeros, that is 1 by alpha plus 1 by beta. We got that alpha plus beta by alpha beta. To find the value of alpha plus beta, we use this equation. Okay, because alpha and beta are the zeros of this polynomial. Okay, we found the value of alpha plus beta by using the relationship between the zeros and the coefficients minus b by a. So we got that as minus 8 by 1. So value of alpha plus beta is minus 8, and we found the value of alpha beta as by using the relation, that is c by a. So 6 by 1, so alpha beta value is 6. We use these values in the sum of zeros, that is alpha plus beta value is minus 8 by 6, alpha beta value is 6. So if we simplify that 1 by 2 4s are 2 3s are, we got the sum of zeros as 4 by 3, and we found the product of zeros, that is zeros are 1 by alpha and 1 by beta. So product of those two is 1 by alpha into 1 by beta. So we got that as 1 by alpha beta. So alpha beta value is 6. So product of zeros is 1 by 6. We use these two values to find the polynomial, that is alpha plus beta is sum of zeros minus 4 by 3. We replace that alpha plus beta as minus 4 by 3, and product of zeros alpha beta value is 1 by 6. So substitute the value of alpha beta as 1 by 6. Okay, now to remove the denominator, we use the LCM of, we can substitute the value of k as the LCM of these two denominators. Okay, LCM of 3 and 6 is 6. Okay, so we substitute the value of k as 6. Okay, we can use any number multiple of 6. Okay, so after multiplying, we got the required polynomial as 6x square plus 8x plus 1.